boys and girls, ladies, gentlemen, and everybody else, welcome to our first delve into calculus here in our first video lesson from chapter 11 on limits. Here we go, here we go. A limit is the value of a function as it approaches a certain point on the x-axis, which we're going to call c. So the limit of a function, the limit is the value of the limit as a function approaches a certain value x, which we're going to call c. A certain x value, which we're going to call c. In other words, if I have a function like f of x is equal to 3x plus 1, the limit of the function as x approaches 4 would be about 13, because as x gets closer and closer to 4, our value of our function has become closer and closer to 13. Okay? There are three particular cases when limits do not exist. The first one is if the function will come to a different value from the positive side, the right side, and the negative side, the left side of my limit value. So from the different sides of c, if c is here from the right side, the positive side if we come to some value, and from the left side if we come to a different value, that limit does not exist. The limit will not exist if our value becomes infinitely large or infinitely small. And the third time a limit does not exist is when the function, the value of the function oscillates between two or three different things. Okay? We're going to do a problem right now, and again, this all makes more sense when we do it in class as well. Okay? So we're looking at this function right here. This is a piecewise function. One side of it is pretty straightforward and pretty simple. It's a constant function. In other words, everything to the negative side of x equals 5, we have a constant function of y equals 3. And on the right side, the positive side of x equals negative 5, we have this rational function, this pretty yucky looking thing right here. But let's just review rational functions for a minute. Okay? I'm going to factor my top. Get rid of this. I'm going to factor my top, so I have x minus 2 and x minus 3. Do you see, folks, right now, I'm going to have a hole at x equals 2. And sure enough, if you look on my graph, I have a hole right here at x equals 2. Okay? I have vertical asymptotes. At x equals 4 and x equals negative 3. And sure enough, I have a vertical asymptote at x equals negative 3. Then I have a vertical asymptote at x equals 4. Okay? And then I also have a horizontal asymptote at y equals 0 on the x-axis, because the degree of my bottom is bigger than the degree of my top. Just looking at this graph, can I figure out some limits as x comes to different numbers? For example, looking at a graph, what would be the limit as x goes to 3? Well, looking at x equals 3, that's right here on my graph. X equals 3. When x comes to 3 from the left side, it's approaching, it looks like about 0. When x is approaching 3 from the right side, the positive side, it also looks like it's approaching 0. So, there's about my point when x is 3. It looks like it's about 0. We can do something called direct substitution and let x be 3. And if x is 3, you see, because of this factor up top right here, I'm going to get 0 in my numerator. So sure enough, this limit is 3. What's the limit as x goes to 2? Again, first of all, we cannot directly substitute, because if x is 2, I have a hole. I have a hole on my graph right there. If I change colors, let me change to yellow, then I go to bright green. If x is 2, I know I have a hole, so the function does not exist at 2. However, what is the value of my limit at x equals 2? Well, again, from the left side, from the negative side, it looks like it's getting close to 0. From the right side, from the positive side, it looks like it's getting close to 0. This looks like it's about 0 once again. You know, using I could do some direct substitution and look at some other things to figure out what this might be. But it looks like it's about 0, maybe a little bit more. Okay. How about as the limit as x goes to -3? Well, -3 on my graph, of course, is right down here. There's my -3. Well, this is where my graph becomes asymptotic. All right? X is actually approaching infinity. That being said, the limit technically does not exist. So we like to say it's infinity. It's just really big. It's big as x gets as x goes to 3, and that's or -3, and we know that because of that factor in the bottom, my denominator is going to be 0. How about the limit as x goes to 4? Same idea. I have a vertical asymptote. Let me switch colors here. Let's go. We'll go orange. Okay. I have a vertical asymptote when x is 4. Notice on the left side, I'm approaching negative infinity. From the right side, I'm approaching positive infinity. So once again, my limit does not exist, and it goes to either negative infinity or positive infinity. And then as x approaches -5, again, they do not exist here because from the left side, x is equal to -3, and from the right side, our function, our graph is approaching, it looks like pretty close to 0 as we're getting close to our horizontal asymptote. So in this case, we had a limit in 2 cases, and we did not have a limit in these 3 cases. Okay, we're going to be talking about different ways to find the limits of functions. And the easiest way to find is something called direct substitution. That's where you take the value of x that we're taking our limit to and plug that right into our function and see what happens. In this particular case, we don't even, when this technique works, we really don't even need to take the limit because we can find the value of the function itself. But in this particular case, I want to find the limit of the function. I don't want to change that color. The limit of the function as x gets closer and closer to 2. Well, all I'm going to do is direct substitution, and I'm going to replace x with 2 and plug it in here, and you can see I'm going to get 8. So the limit is going to equal 8. The limit as x goes to 2 is 8. Another method is to use your calculator. Let's just say, for example, I wanted to try direct substitution here. I'm looking for the limit as x goes to 0, right? So if I try to directly substitute, I'm going to get e to the 0 minus 1 over 0. Well, e to the first is 1. 1 minus 1 is 0 over 0. Well, 0 over 0, I have no idea what that is. But I can find the limit by looking at my graph on the calc, or I can look at the table on the calc. For example, you put this in, and I did this, and I lost it in a previous version of your video. But any which way, if I look at my video and I let x be 0, so I'm going to go to my table set and change that to small increments. So I'm going to go like, for x, I'm going to go 0.3, 0.2, 0.1, 0, -0.1, etc. Look on the table and see what I get for y. And I'm actually going to find that as x goes to 0, the limit of this function is approximately 1. By looking at my graph and or by looking at my table feature.